Okay, welcome to this Edexcel Mathematics Paper 1 Non-Calculator Higher Tier paper from Tuesday the 19th of May 2020. We've got 1 hour 30 minutes to do this, so let's get to it. Okay, question 1. The first 5 terms of an arithmetic sequence are 1, 4, 7, 10, 13. Write down an expression in terms of n for the nth term of this sequence. So we go straight to the cheat sheet. An arithmetic sequence, they have a common difference, which is where you're going to add or subtract the same amount each time. We're going to ask the question, well, what is the common difference? And we're going to multiply n by this value in our equation. And how does this differ from the sequence? So let's have a look. Well, we can say that the difference each time is going to be plus 3. This. So what I'm just going to draw underneath in green here, well, that's going to be, it's almost like this would be starting at 3, then 6, then 9, then 12, then 15. So for the first part of the expression, I'm going to just call this 3n. So in the first term, it's going to be, if n is 1, it's going to be, on the first term, n would be 1. So 3 times 1 would be 3. On the second term, it would be 2n, so that would be 3 times 2. Third term, it would be 3 times 3, and so on and so on. But how do we get these green numbers into these black numbers here? Well, each time here, we need to subtract 2. So it's going to be 3 minus 2 is going to give you 1, 6 minus 2 is going to give you 4, 9 minus 2 is going to give you 7, and so on and so on. So it's going to be 3n minus 2. Okay, so question 2. Show that 2 1/3 multiplied by 3 3/4 equals 8 3/4. So if we just quickly go to the cheat sheet, it's very simple, this one. We're just going to convert them into improper fractions, and then we're going to multiply it out. So when we have 2 1/3, how can we get that into improper fractions? Well, we are working in thirds. So how many thirds are in 2? So if we look at this red section here, well, in 1, we're going to have 3 thirds to make up 1 whole. And then for 2, we're going to have another 3. So that is going to be 6 thirds in 2, plus the third here to give it, that's going to be 7 thirds. I'm going to multiply. And then here we have 3 3/4. Well, how many quarters are in 3? Well, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And don't forget to add on those 3/4 there. So that's going to be 15 over 4. So what does that equal? Well, when we have a fraction like this, we need to multiply the top and multiply the numerators, multiply the denominators, and then we need to work out what we have. So 7 multiplied by 15, well, that is going to be 105. 3 multiplied by 4 is going to be 12. Can we make this a little bit simpler? I believe we can if we divide the top and the bottom by 3. So 105 divided by 3 is going to be 35. 12 divided by 3 is going to be 4. And what does that equal? So we know that well, 8/4 is going to be 8 times 4, which is going to be, so 8 is going to equal 32 over 4. And then that is going to leave us, to get to 35, that is going to be, leave us the 3/4. So that is going to equal 8 3/4. Okay, so question 3, the diagram shows 4 graphs, which we have here, graph A, graph B, graph C, graph D. I'm going to go straight to the cheat sheet. So I think it's a really good idea here to have some familiarity with the graphs in GCSE, particularly x squared and x cubed. But if you are unsure about those, what you could do is you could sub in x for a few values of each graph just to get an idea of the shape, and see what we how the graph would take shape. Okay, so again, like I said, you should be familiar with this one. This should be very familiar, this graph D. You should know that this one is going to be y equals x squared. You should also know with graph C that this is going to be y equals x cubed if it takes this shape. That might give you a bit of an idea for graph B, because it's kind of like graph C, but just sort of the opposite, the inverse. So that is going to be y equals minus x cubed. So we know that graph B is going to be y equals minus x cubed. It's going to be B. Y equals x cubed was graph C. Y equals x squared was graph D. And by process of elimination, we can say that this is going to be graph A. So question 4, the diagram shows 4 triangles. We've got triangle A here, triangle B, triangle C, triangle D. 2 of these triangles are congruent. I'm just going to underline that word there, congruent. Write down the letters of these 2 triangles. Well, if we go to the cheat sheet, if something is congruent, it basically means that the triangle is exactly the same, but maybe it has just moved position, or maybe it is reflected, or it has been turned. And a good way to figure this out is if all 3 sides are the same. If you have side, angle, side, so if you have one side with an angle in the middle and then another side, that's another good way to do it. You've got angle, side, angle with the side in the middle. And then the last one here, you could have the right angle with the hypotenuse and then one of the sides. And second part of the cheat sheet, we're going to add in any angles with the triangles where possible. So let's see what we have here. Well, I think with triangle A, we've got 2 of the angles here, and we know that in a triangle, the angles add up to 180 degrees. So this angle here is going to be 180 minus this 55 here, minus this 45, and that is going to leave us with an 80-degree angle. So let's just put that in. This one I can't really do anything with, triangle B. Triangle C, again, we've only got the one angle to work with. I can't really add anything different. This one again, I can. I've got an 80-degree angle here. I've got a 45-degree angle. So what is this missing angle here? Well, that is going to be 180 minus this 80 degrees here, minus this 45 degrees here, and that is going to give us 55 degrees. So as you can see, I'm just going to change the color. We do have this 10 centimeter here. We have this 10 centimeter here. And this 10 centimeter is in the middle of an angle of 45 degrees and in the middle of an angle with 55 degrees. So I think that these 2 are congruent. We have angle, side, angle from the cheat sheet. Just going to put that in, angle, side, angle. So it's going to be triangle A and triangle D. Okay, question 5 now. Sean pays £10 for 24 chocolate bars. Okay. He sells all 24 chocolate bars for 50p each. Work out Sean's percentage profit. So if we just quickly go to the cheat sheet, we're going to ask the question, well, how much money does Sean make by selling these bars? We're going to work out his profit. Remember, he paid £10 at the beginning and he's sold them for an X amount, so we need to work out the profit. But when we work out the percentage profit, it's going to be the difference divided by the original price, and then we're going to multiply this by 100. Okay. So let's just write that in. Well, he pays £10 for the 24 chocolate bars. So he's paid out £10 for those bars. He sells all 24 chocolate bars for 50p each. Well, I'm just going to say that 50p, because we're working in pounds here, I'm just going to say that 50p is going to equal 0.5 pounds. So it's going to be 24 multiplied by 0.5 or multiplied by a half. And if we multiply by a half, we divide by 2. So 24 divided by 2 is going to be 12. Let's say 12 pounds. So let's put this in green. The profit, it's going to equal 12 minus 10, which is going to be £2. Okay, so the percentage profit is going to equal the difference divided by the original price, and then this number here is going to be multiplied by 100. Well, we know that the difference here, or the profit, is going to be £2, the difference between 12 and 10. We're going to divide this by the original price, which was 10, and multiply this by 100. Well, 2 over 10, we could say is going to be, well, that's going to be 0.2, and 0.2 multiplied by 100 is going to give us 20%. Okay, number 6, ADC is a triangle, which we have here, ADC, AED, and ABC are straight lines. Okay, EB is parallel to DC. Angle EBC equals 148 degrees. Angle ADC equals 63 degrees. Work out the size of angle EAB, which is this one at the top. You must give a reason for each stage of your working. So if we go to the cheat sheet, we need to know that alternate angles are equal. We would call these Z angles. We wouldn't name it Z angles in the exam because you wouldn't get a mark. You need to say alternate angles, but they have this Z shape. Number 2, corresponding angles are equal, and these are known as F angles. Again, we call them corresponding angles in the exam, not F angles, because you won't get the mark. Co-interior angles add up to 180 degrees, and this is going to take the shape of a C or a U. These two angles will add up to 180 degrees. The angles on a straight line add up to 180 degrees, and the angles in a triangle add up to 180 degrees. So these are really important, 5 really important points when it comes to questions, when it comes to parallel lines. Okay, so what can we do with this question? Well, immediately what I can say is that I can see this kind of F shape here. I'm just going to draw this in. We're using the straight line and the parallel lines that come off it. So we have this angle here, but also we're going to have this corresponding angle here. So this angle EDC, which is 63 degrees, is going to be the same as this angle here, this AEB. That also is going to be 63 degrees. And we're going to write angle AEB equals angle ADC, which equals 63 degrees. And we're going to write because corresponding angles are equal. So what else can we find out here? Well, I'm just going to put this into green. Well, what I can also say here is we have this straight line, and we have this angle here, this ABC, which is 148 degrees. Well, this is on a straight line. And all angles on a straight line add up to 180 degrees. So it's going to be 180 minus 148, which is going to give us 32 degrees. And we're going to write something like this. It's going to be angle EBA equals 180 degrees minus angle EBC, which is that 148 degrees here. And that is going to give us 32 degrees. And the reason is going to be because angles on a straight line add up to 180 degrees. And for the last part, well, again, I can see that we have a triangle here at the top. I'm just going to put this in a green color. It's not very neat, I apologize. And we should know that the angles in a triangle, all of the angles in a triangle are going to add up to 180 degrees. So we've got this angle here at AEB, which is 63 degrees. We've got this angle here at EBA, which is 32 degrees. So we just need to subtract those two from 180 degrees to get X, or to get angle EAB. And if I just zoom out a little bit more, so yeah, that is going to give us, so angle EAB is going to equal 180 degrees minus angle EAEB, which is 63, minus angle EBA, which is 32 degrees, and that is going to give us 85 degrees for angle EAB, and that is our answer. Okay, so question 7. The table shows information about the heights in centimeters of a group of Year 9 girls. We've got the least height is 150 centimeters, the median is 165 centimeters, the greatest height is 170 centimeters. This stem and leaf diagram shows information about the heights in centimeters of a group of 15 Year 9 boys. And we've got this information here in the stem and leaf. And just as a bit of a reference, the key is 15/8 is going to equal 158 centimeters. So this here is 158, 159, 159, and so on and so on. Compare the distribution of heights of the heights of the girls with the distribution of the heights of the boys. So we just go to the cheat sheet. Well, the range is going to equal the greatest height minus the or subtract the least height. And to find the median on a stem and leaf diagram, you need to cross off the numbers from the outside and work your way to the inside. And with a distribution here, we're going to compare the ranges of the distribution between the boys and the girls. And for part 4, we're going to compare the medians of the distribution between the boys and the girls. So we need to find out those pieces of information. I'm going to start with well, we know that the median for the girls is this one here. It's going to be 165 centimeters. We know that the least height is 150 centimeters. We know that the greatest height is 170 centimeters. So I'm going to put here the girls' range equals, I just have to go off the page a little bit here. It's going to be 170 minus 150, and that is going to give us 20 or 20 centimeters. The boys' range, that is going to equal, well, the least height is going to be this 158 here. And the greatest height is going to be this 182. So it's going to be 182 minus 158. And that is going to give us 24 centimeters. What about the median? Well, we know that what the girl's median is. It tells us in this chart here. It's 165 centimeters. Well, if we want to find out the boy's median on this stem and leaf, the way to do this, you need to just cross off. You start on the outside, work on the outside ranges, and you work your way in. So one from the bottom, one from the top, one from the bottom, one from the top, and just keep going. Keep going, keep going, keep going, and you should be left with one number, and that is going to be 168. So boys' median equals 168 centimeters. So we are going to write something like this. The range in height is greater for the boys, which is 24 centimeters, than for the girls, which is 20 centimeters. And also we're going to comment on the median. So the median height is greater for the boys, which is 168 centimeters, than for the girls at 165 centimeters. And if you want, you could add a little comment just to say, well, so therefore the boys on average are taller. Okay, so question 8. The diagram shows a prism placed on a horizontal floor. We've got this prism here with a height of 3 meters here, and we've got this pressure equals force over area. So the prism has a height of 3 meters, which we have here. The volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force exerted by the prism on the floor. So what do we have? Well, we know the pressure, that is going to equal 75. The question wants us to know the force, which we don't know yet, that is in the question. And the area, again, at the moment we don't know what the area is. And we're going to have to do something to figure that out. So if we go to the cheat sheet, well, the volume of a prism is going to be the base area of the prism multiplied by the height. So basically, I'm just going to draw this in red, this floor here. It could also be this top part here, just the base area, multiplied by the height. So this area here multiplied by the height is going to give us the entire volume of the prism. Okay. And what we could do here is just to rearrange this formula. So if we have the volume of the prism equals the base area of the prism multiplied by the height, we could just rearrange this formula to be the base area of the prism equals the volume of the prism divided by the height. And this is what we are going to use to find the base area. So, so the base area is going to equal the volume, which is 18, divided by the height, which is 3, and that is going to give us 6 meters squared. So I'm just going to write that in now. So I'm just going to delete this question mark because we do know what it is. It is going to be 6. So we need to find the force. So we know that, well, the pressure is going to be 75 equals the force, which we don't know. Just put F there, divided by the area, which we know is 6. So we need just to rearrange this formula. So what we're going to do is we're going to multiply both sides by 6. And that is going to give us F on its own because this is going to cancel out. And 75 multiplied by 6, well, that is going to be, well, what is that going to be? That's going to be 450. Okay, question 9. Write these numbers in order of size. Start with the smallest number. Okay, so we have 6.72 multiplied by 10 to the power of 5, 67.2 multiplied by 10 to the power of minus 4, 672 multiplied by 10 to the power of 4, and 0.0000672 on its own. And if we just look at the cheat sheet here, so just to give you some tips as to what to do if you have something multiplied by 10 to the power of something. For example, if you had multiplied by 10 to the power of 5, we're going to move the decimal point 5 places to the right, so the number gets bigger. We are making that number bigger. However, if we're multiplying by 10 to the power of minus 5, we're going to move the decimal point 5 places to the left, so the number is going to get smaller. Okay. So for this one, we're going to have 6.72. 6.72 multiplied by 10 to the power of 5. So we're going to make this number bigger. And we're going to move that decimal point 5 places to the right. So it's going to be 1, 2. I'm just going to put some extra zeros in here. 3, 4, 5. So that decimal point is going to be there. So that is going to equal 672,000 for this one. I'm going to do this one in blue now. So we have 67.2. Now it's multiplied by 10 to the power of minus 4. So that means that this decimal point is going to go, it's going to make the number smaller. So the decimal point is going to go 4 places to the left. So it's going to go 1 place, 2 places. And I'm just going to put some zeros in there. So it's going to go 3, 4. It's going to go here. So that is going to equal 0.00672. Next one I'm going to put in green. So we have 672 times 10 to the power of 4. So 672, the decimal point is going to be here. I'm just going to put some extra zeros in here. And this decimal point, it's going to make the number bigger. So 672 is going to go bigger. So we need to move this decimal point 4 places to the right. So it's going to go 1, 2, 3, 4. So it's going to go there. So that is going to equal, what is that going to be? 6,720,000. Looks about right. And the last one I'm going to do in yellow. I hope you can still see it. Actually, I don't need to do anything, do I? It's there's no multiplication to be done. So, what do we have here? So, what is, I'm just going to write that out anyway. I'm just going to write out 0.00672. So what is it at? Start with the smallest number. We need to put them in order. Well, what is going to be the smallest? Well, this one has 3 zeros before the 672. This one only has 2. So this one is going to be the smallest. Then this one. Then we have 672,000 or 6 million. So this one is going to be number 3, and this one is going to be the largest, the 6 million one. So we just need to write these out now. So we have, for the first one, we have 0.000. Just be really careful you don't make any mistakes now because you've done all the hard work. Second one is going to be this 67.2 multiplied by 10 to the power of minus 4. Number 3 is going to be this 6.72 multiplied by 10 to the power of 5. And this number 4 is going to be 672 multiplied by 10 to the power of 4. Okay, so question 10. Given that a divided by b equals 2 over 5 and b over c equals 3 over 4, find the ratio of a to b to c. So if we just quickly go to the cheat sheet now. So what we're going to do immediately, we're going to convert these fractions into ratios. Part 2, so as b appears in both ratios, we need to manipulate both sets so that b equals the same in both of these ratios. So when a to b and b to c, we want these b's to be the same. And if we can do that, now we can find the ratio of a to b to c. So we have a to b, so I'm just going to write that in. I'm going to put this in red. So a to b, so a is 2, b is 5, so I'm just going to put 2 to 5. And over here we have b over c is 3 over 4, so I'm going to put b is, b to c is going to be the same as 3 to 4. Okay, so as you can see now, b in this red section with a and b, b is 5. In this blue one, b is 3. I want to try and get these b's equal. So what I would do here, you want to try and think of a common number between these two. So you're going to have, I would just multiply them together. And that's going to give us 15. So 5 times 3 is 15. So how do we get 5 into 15? Well, we need to multiply this one by 3. And how do we get this 3 into 15? Well, we need to multiply it by 5. So what is that going to give us? Well, that is going to give us, well, you have to do everything with a, b, and c with this one. So a is going to be multiplied by 3. So 2 times 3 is going to be 6. We have this 5 here for the b. That is going to give us 15. Now this one we're going to multiply by 5. So it's going to be, this 3 is going to become 15. Can you see how this and this are now equal? And this c we must multiply by 5 also. That is going to give us 20. So now we can compare. So a to b to c, well, a is going to be 6. b is going to be 15. It's 15 in both of them. And c is going to be 20. Okay, so question 11a, find the value of the fourth root of 81 multiplied by 10 to the power of 8. So let's just quickly go to the cheat sheet. What we're going to do is we're going to split this question into 2 parts. The second part is going to be so if we had x here, if we had the fourth root of x, that is the equivalent of x to the power of a quarter. And then we're going to use the power of a power rule to find out the answer. And if you don't know what this power of a power rule is, it's going to be this one. So if you have a to the power of x, and then all of this to the power of y, you're going to multiply these two powers to get a to the power of x multiplied by y. Okay, so like I said, we're going to split this into 2 equations. So it's going to be the fourth root of 81 multiplied by the fourth root of 10 to the power of 8. Okay. Well, the fourth root of 81, well, if you have 3 times 3 times 3 times 3, or 3 to the power of 4, that will give you 81. So if you work back down, that is going to give you 3. And then multiplied by, okay, this is where it gets a little complicated. So I'm going to put this multiplication in here. So we have 10 to the power of 8. And then all of this is the fourth root. We're going to this is going to be the fourth root of 10 over 8. So remember that the fourth root is the equivalent of x, is going to be the equivalent to x to the power of a quarter. So all of this is going to be to the power of 1 over 4. So that is going to give us 3 times, well, 10 to the power of 8. Remember this power of a power rule, this one here. It's going to be 10 to the power of 8 multiplied by a quarter. So it's going to be 3 times 10. Well, 8 multiplied by a quarter is the same as 8 divided by 4. So that is going to give us 2. And then 3 to the power of 10 squared, 3 multiplied by 10 squared is going to be 100. And 3 multiplied by 100 is going to give us 300. So part B, find the value of 64 to the power of minus a half. Okay, so with this one we're going to use the negative power rule. I'm just going to quickly go back to that one. So the negative power, if we have a to the power of minus x, that is the equivalent of 1 over a to the power of x, where x becomes positive. So for example, if we had 5 to the power of minus 3, this would equal 1 over 5 to the power of 3, and that 3 would become positive. So we're going to have 64 to the power of minus 1 over 2 equals 1 over 64 to the power of a half. And if you're not sure about this to the power of a half, I'm just going to show you this other rule here that we have. We have this the power to a half rule is going to be, so if you have a to the power of a half, it's the same as the square root of a. So if you have 5 to the power of, let's say, okay, 5 to the power of a half, this is the same as root 5. If you have 9 to the power of a half, it's the same as root 9, and so on and so on. So this is going to be the equivalent of 1 over the square root of 64. And I hope you know this. So the square root of 64 is going to be 1 over 8. And that is going to be our answer. Okay, for this one, so we're going to have write 3n, so 3 to the power of n divided by 9 to the power of n minus 1 as a power of 3. So if we go to the cheat sheet, now we're looking for a power of 3, so I'm going to try and convert this 9 into 3 squared to get it in terms of 3 rather than 9. We're going to use the power of a power rule again for the denominator, and then we're going to use the division rule, and I'll show you that in a second if you're not too sure what that is. Okay, so I'm going to leave the top for now. So 3 to the power of n all divided by, well, remember I said we want to get rid of this 9 and get it all in terms of 3. So 9 equals 3 squared. So I'm going to put 3 squared in brackets to the power of n minus 1. Okay, and again now we have this power of a power rule because we have 3 to the power of 2, and then all of this to the power of n minus 1. So again, I'm going to leave the top. And this is going to be 3 to the power of 2 multiplied by n minus 1. And so we have 3n over, that's going to be 2n minus 2. If we multiply this out, so 2 multiplied by n, 2 multiplied by minus 1. And now we have this division rule because we have 3 to the power of something divided by 3 to the power of something. So what do we do with this division rule? So if we have a to the power of something divided by a to the power of something, or a to the power of x divided by a to the power of y, it's going to be a to the power of x minus y. Do you see that we subtract the powers? So if we have, let's say, 4 to the power of 9 divided by 4 to the power of 5, that is going to be the equivalent of 4 to the power of 9 minus 5, which would be 4 to the power of 4. Okay. So we have 3 to the power of n divided by 3 to the power of 2n minus 2. So I'm going to put 3 to the power of n minus, and I'm going to put this in brackets just so we don't get confused. It's going to be to the power of 2n. So 3 to the power of n, subtract this. So we're going to have 3 to the power of n. Well, n minus 2n is going to be minus n. And then we have minus 2, which is going to be plus 2. You could maybe leave it like that, but I'm just going to put it as 3 to the power of 2 minus n. Okay, so question 12. The table gives information about the weekly wages of 80 people. So we have this frequency table here. Part A, complete the cumulative frequency table. So I'm just going to go straight to the cheat sheet now. So cumulative frequency it's kind of like a snowball effect. So we're going to keep adding to it as we go along. It's going to constantly get bigger and bigger and bigger. In part 2, so the last number in the cumulative frequency table should be the same as the total number of people given in the question. So the question tells us it's 80 people. So the last number in the cumulative frequency table should be 80 also. So we have the wage between 200 and 250 pounds is 5 people. So again, 200 to 250 is going to be 5. Between 200 and 300 is going to be this between 200 and 250 and 250 to 300. So we're going to add this 10. It's going to be 15. Between 200 and 350 people we're going to add this 20 on. So it's going to be 35. Add the 20 is going to be 55. Add the 15 is going to be 70. And add the 10 is going to be 80. And like I said, does this number match this number? Yes, it does. Part B, on the grid opposite, draw a cumulative frequency graph for your completed table. Okay, so as a cumulative frequency graph is like a snowball effect, which is like I told you before, we're going to put the mark at the end of the class width, not the midpoint like you would do with a frequency polygon, which is another graph that you would see GCSE. It's going to be at the end of the point. And second thing, really important, it must be a smooth curve linking the marks. It's not going to be a straight line like a frequency polygon also. So don't use a ruler for this. You really need that smooth line, smooth curve. Okay. I'm going to admit, this is not the easiest thing to do on the computer. So this isn't going to be the best. It's not going to be very neat or accurate, but I'm going to do my best. So like I said, we've got this range here between 200 and 250. We don't choose the midpoint, which would be 225. We always choose the end point with a cumulative frequency table. So it's going to be at 250 pounds, we're going to have 5 people. So 5 people, let's find it. So 5 people, 250, go to 5. 300 people earn less than, 15 people earn less than 300 pounds. Just go to here. 35 people earn less than 350. Um, 55 people earn less than 400. And then 70 people earn less than 450. And then 80 people earn less than 500. So just go all the way to the top. And like I said, I'm not looking forward to doing this. I'll put this in black, but I do need to try and draw a smooth curve for this. It's not going to be, it's awful. Like I said, guys, it's really not the best. I really try as hard as I could, but that is as good as I can do on this using the stylus. It's very difficult. Okay, Juan says 60% of this group of people have a weekly wage of £360 or less. Is Juan correct? You must show how you get your answer. So if we go straight to the cheat sheet, we're going to work out 60% of 80 people. Because there's 80 people in this, and he said 60% have a weekly wage of £360 or less. We're going to draw a straight line from £360 to the line of best fit on the cumulative frequency graph, and then we're going to draw a line to the cumulative frequency, and then we're going to ask the question, well, is this more or less than 60% of the 80 people? Okay, so let's see what we have. So first things first, if we know that there's going to be 80 people, as we were given in the question, well, 10% is going to equal 8. 60% is going to equal, well, we'll just say 8 times 6, which will be 48 people. Okay, let's square that off. Just keep that in mind. And what did he say? So he said 60% of this group will have a weekly wage of £360 or less. So I'm just going to draw in that line now. I'll draw it in green. So we're going to find 360. Well, if this is 350, this is 400. I think it's going up in fives. So 360 is going to be this one here. And I think more or less, just put that in there. I think this is going to be 40 people. So 40 people are going to have a wage of £360, this part here, or less. Okay, so only 40 people have a weekly wage of £360 or less. And as 40 is less than the 48 that we worked out before for 60% of the people, so as 40 is less than 48, Juan is incorrect. And as less than 60% of people have a weekly wage of £360 or less. Okay, so question 13, liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 70 kilograms per meters cubed. Liquid A has a mass of 1400 kilograms. Liquid B has a density of 280 kilograms per meters cubed. Liquid B has a volume of 30 meters cubed. Work out the density of liquid C. Now I've just got this little graph. So what we have is density equals mass divided by the volume. And that's what I put here on the cheat sheet for part 1. What we're going to do, we're going to find the missing volume and mass of A and B. And then at the end, we're going to find the density of C. We're going to find the total mass of A and B divided by the total volume of A and B. And that is going to give us the density of C. So, let's see, let's start with A. So what do we have here? Well, we have the density. The density is 70 kilograms per meters cubed. We've got the mass. It gives us the mass, and that is 1,400. But we want to find the volume. We don't know that yet. So if we want to find this volume here, we need to have the mass divided by the density. So volume is going to be mass divided by the density. Well, mass is going to be 1,400. The density is 70. And to make this a little bit easier on yourself, just cancel out a 0 from the top and the bottom. And then 140 divided by 7 is going to be 20. And I'm just going to put that reference. So the volume is going to be in meters cubed. And what I might do is I might just quickly put that in here. So the volume is going to be 20 meters cubed. So we have everything we need now for A. Okay, let's go to B. Again, well, the density of B we are given, it's 280. The mass is, we don't know the mass. I'm just going to put a question mark there. Do we know the volume? Yes, we do. It's going to be 30. So if we want to find the mass here, it's going to be the density multiplied this time by the volume. Well, the density is going to be 280. The volume is going to be 30. And in order to do this quickly, you could do this with a multiplication grid if you wanted to, or something like that, but I would just ignore these zeros for now and look at 28 multiplied by 3. Well, 28 plus 28 is going to be 56. And then add a third 28 is going to be 84. And then we're just going to add on the two zeros. And don't forget to add so we're talking about mass here, so mass is going to be in kilograms. And again, I'm just going to add that in. So we're going to have 8,400. Shimmy this down a bit. So now I'm going to put this into green. We want to find the density of C. Now remember, the density is going to be the total the total mass of A and B divided by, if we go to the cheat sheet, the total mass of A and B divided by the total volume of A and B. So the total mass will have 1,400 for the mass of A, and then the mass of B is going to be 8,400 divided by the total volume is going to be, we have 20 for A and we have 30 for B. Okay, so we have 1,400 plus 8,400. That is going to be 9,800. And then 20 plus 30 is going to be 50. Just move that down a bit more. I'm just going to take a 0 of both of these. So it's going to be 980 divided by 5. And again, you could probably work this out quite easily, but I think if you're not really sure, you could just do something like this. So how many 5s go into 9? That's going to be 1. Carry the 4. How many 5s go into 48? Well, that is going to be 9. Carry the 3. How many 5s go into 30? That is going to be 6. So the density of C is going to equal 196 kilograms per meters cubed. Okay, so question 14. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game they play, the probability that Sally will win against Martin is 0.3. The probability that Sally will draw against Martin is 0.1. Work out the probability that Sally will win exactly one of these 2 games against Martin. Okay, so let's go to the cheat sheet. So for part 1, we're going to draw a probability tree here. This is going to help a lot with this question. We're going to identify which combinations equal 1 win only. So we don't want 2 wins, we don't want 0 wins, we want 1 win only. And to work out the probability of the combination of the 2 games, we're going to have the probability of game 1 multiplied by the probability of game 2. And then at the end, we're going to add all combinations together to give the final probability. Okay. So very quickly, what I'm going to do is just to say the probability of to lose. Well, the probability of a win is 0.3. The probability of a draw is 0.1. So I'm going to say the probability of lose is the probability of 1 minus 0.3 minus 0.1. And that is going to be 0.6. So the probability that she wins is 0.3, the probability that she draws is 0.1, the probability that she's going to lose is 0.6. Okay, so I've just drawn this probability tree here, and now I'm going to put the probabilities of each one in. So the probability of all of the wins is going to be 0.3. So I'm just going to put all of these in now. The probability of a draw is going to be 0.1. And the probability of losing is going to be 0.6. Okay, so remember, we need to find the probability of only one win. Well, if she wins the first game this way, She can't win again because that would be 2 wins, but she can draw and she can lose. If she draws the first game, if she draws again or loses again, that would be 0 wins, so that's no good. But if she wins the second game, that is 1 win, so that's good. And if she loses the first game, she must win the second game. So what are the probabilities of these? Well, the probability of this one here is going to be 0.3 multiplied by 0.1. The probability of win-lose is going to be 0.3 multiplied by 0.6. The probability of draw-win is going to be 0.1 multiplied by 0.3. And the probability of lose-win is going to be 0.6 multiplied by 0.3. Well, 0.3 multiplied by 0.1 is going to be 0.03. And you could probably say the same for draw win, because that is going to be exactly the same. 0.1 multiplied by 0.3 is going to be 0.03. So for win lose, it's going to be 0.3 multiplied by 0.6, so that is going to be 0.18. And the same for the lose win, that is going to be exactly the same. So now we just need to add up these probabilities to give us the total probability of 1 win. So it's going to be 0.03, 0.18, 0.03, 0.18. So what is that going to give us? Well, that's going to be 3 at 8, that's going to be 11, 14, 22, carry 2, 2, add 1 is going to be 4, put the point in, and that is going to give us a probability of 0.42. Okay, so question 15. The straight line L1 has equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through the point 9,5. Find an equation of the line L2. So if we go to the cheat sheet, well, the formula for a straight line is going to be y minus y1 equals m, and then in brackets x minus x1. And for this equation, all we need is one set of coordinates on the line, which would be the x1, y1. And we do need the gradient also, which was going to be m. Luckily, we've been given the coordinates of a point on the line. We've been given 9, 5. And something to find the gradient, we need to remember that perpendicular gradients, when a line goes this way and a line goes this way, the gradients are going to be perpendicular. And to work this out, we're going to have the gradient of the line 1 multiplied by the gradient of line 2 is going to give us minus 1. Really useful to remember. Okay, so, well, we know that we don't know what the gradient of line 2 is yet, but we are given this. We are given y equals 3x minus 4 for the first line. And this is in the form of y equals mx plus c, where m is the gradient. So I know that m1 equals 3. The gradient of line 1 is going to equal this number here, 3. And remember, if we have m1 multiplied by m2 equals minus 1, well, this m1 is going to be 3 multiplied by m2 equals minus 1. And what I'm going to do is I'm going to divide both sides by 3, and that's going to cancel this out. So what we're going to have is we're going to have m2 is going to equal minus 1 over 3. Just going to put this into green now. So remember, we had this equation from the cheat sheet. If I just show you, we had y minus y1 equals m, and then brackets x minus x1, close bracket. So y minus y1 equals m, and then x minus x1. So if I just put this to the side, well, we know that m is going to be minus 1 over 3. And then, like I said, we've already got the point that is on the line. That is on line 2. So x1 is going to be 9 from here. And y1 is going to be 5. Just going to put this in a little box. So y1 is going to be 5, y minus 5. M is minus 1 over 3. X1 is 9. So we have y minus 5. Let's just tidy it up. So minus a third multiplied by x is going to be minus a third x. And then minus a third multiplied by minus 9. Well, a minus multiplied by a minus becomes a plus. So it's going to be plus, it's going to be plus 3. And then I want to get rid of this minus 5. So I'm going to add 5 to both sides, which is going to give us minus 1 over 3x plus 8. And that is the answer for this question. Okay, question 16. Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees. She puts a mark on each bee and returns them to her hive. On Tuesday, she catches 120 of the bees. She finds that 20 of these bees have been marked. Work out an estimate for the total number of bees in her hive. Okay, so if we look at the cheat sheet, we know that 20 out of 120 bees were marked on Tuesday. And this is the equivalent of 1 in 6. So 1 in 6 bees were marked on Tuesday after marking them on Monday. We're going to use this fraction to make an assessment of what that means for the 90 bees the day before. Okay, so let's see. So we have, we know on Tuesday that she catches 120 bees and 20 of them have been marked. So we know that 20 over 120 have been marked. And this is the equivalent if we just divide it all by 20, 6. So 1 in 6 bees marked after marking them on Monday. So on Monday, she caught 90 bees from the hive. And on the following day, she realized that a sixth of them had been marked. So we can assume that 90 of the bees she caught on Monday, they're going to be the equivalent of 1/6 of the total number of bees. So we can assume that on Monday, 1/6 of the bees were marked. And therefore, 90 bees is going to equal 1/6 of the total number of bees in the hive. So if 90 is 1/6, well, I'm going to multiply this by 6 to give us the total. And that is going to give us 540 bees. And that is my estimate. So part B, Shirley assumes that none of the marks had rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, explain what effect this would have on your answer to part A. So if we go to the cheat sheet, if some of the marks had been rubbed off, more than 20 out of 20 would have originally been marked. For example, it could be 30 out of 20, which would be 1 in 4, rather than the 1 in 6. And for example, part 2, 30 out of 120 could have been marked, which would be 1 in 4. What effect would this have on the 90 bees captured the day before? So if 90 bees were only 1 in 4 rather than 1 in 6, what effect would that have? If none of the marks had fallen off and it was a 20 out of 120 or 1 in 6 had been marked, then we know from part A that it would be 90 multiplied by 6, which would give us 540. But if some of the marks had fallen off, and for example 30 out of the 120 bees had been marked, which would be 1 in 4, we would then have to multiply that 90 by 4 to find out how many bees were actually marked, and this would give us 360, which is less. So for my answer, I'm going to put the answer would be an overestimate. It would be less than 540 bees. Question 17, make F the subject of the formula D equals 3 with 1 minus F in brackets, 4 minus F. Now remember, if you're not sure what to make the subject of something is, D is the subject currently, because it's D equals something. So at the end of this, we want to have F equals something. So if we go to the cheat sheet, we're going to get rid of any division first and expand the brackets. We're going to gather all F values on one side. We're going to gather everything else on the other side. And then we're going to factorize F to get it alone. So let's see what we have here. So I want to get rid of this F minus 4. So I'm going to multiply both sides by F minus 4. So that's going to be D F minus 4 equals 3 and then 1 minus F. I'm going to expand the brackets. So it's going to be D multiplied by F is going to be DF. D multiplied by minus 4 is going to be minus 4D. 3 multiplied by 1 is going to be 3. 3 multiplied by minus F is going to be minus 3F. Now I want to get all of these F values on one side, all of the other values on the other side. So I'm going to add 3F to both sides to get this 3F over here. So that's going to be DF minus 4D plus 3F equals 3. I want to get this 4D away from the F, so I'm going to add 4D to both sides. So it's going to be DF plus 3F equals 3 plus 4D. And now I'm going to factorize that F. So we've got the F values on one side, everything else on the other. I want to factorize F, just pull it out of the equation. I'm going to switch to blue. So how do I get DF from F? Well, we multiply by D. How do I get 3F from F? Well, I need to multiply by plus 3. Equals 3 plus 4D. And how do I get F on its own? Well, I'm going to now divide by D plus 3 on both sides. That's going to give me F equals 3 plus 4D all divided by D plus 3. Okay, so question 18. X is proportional to root Y, where Y is greater than 0. Y is increased by 44%. Work out the percentage increase in X. Okay. So if we look at the cheat sheet, well, x1, or the original x, is going to be, when we're working with proportions, if it's directly proportional, it's going to be k root y. And then when we're looking at what happens to x after this increase in y by 44%, it's going to be this. It's going to be x equals k root 1.44 y. This y is going to increase by 1.44. We're going to increase by 44%. And then this part here, this root 1.44y is going to equal root. We can split this into 2. So it's going to be root 1.44 multiplied by root y. So x1, well, x1 is proportional to root y. But this means that x1 equals, we need this value k, this value that we don't know what it is, k root y. Y is increased by 44%. Work out the percentage increase in y. So we know that this y is increased by, I'm just going to draw this line here, this y is increased by 44%. So this second x is going to equal k root 1.44y. And here with this, I think a good idea is going to be to split this. So root 1.44 root y. Well, root 1.44, if you imagine this is 144 rather than 1.44, well, the root of 144 is going to be 12. So what this is going to leave us with is 1.2. 1.2 root y. And I'm just going to, just to make this a bit more obvious, I'm going to move this. So we have k multiplied by 1.2 multiplied by y. I'm going to put this 1.2 at the front, just to make it a bit more obvious. So 1.2k root y. So can you say, if I put this x2 here, can you say the difference between x1 and x2? after this increase in 44%. It's exactly the same. It has x1 equals k root y, x2 equals k root y, but with this 1.2 at the beginning. So if this is the equivalent of x1 equals 1k root y, and this is 1.2k root y, what is the percentage increase? Well, that is going to be a percentage increase of 20%. Okay, so question 19. F and g are functions such that f of x equals 12 over root x, and g of x equals 3, and then in brackets multiplied by 2x plus 1. Find G5. Okay, so we're going to substitute, actually no, let's go to the cheat sheet. So I'm just going to look at this one now, this number 1. We're going to sub 5 for x into the equation and just work it out. So we have g of x equals, let's put that in, so g of x equals 3 to x plus 1. So g of 5, well this 5 is going to take the place of x, wherever x is. So we work out whatever's inside the brackets first, so keep this 3 out. It's going to be 2 multiplied by 5, which is going to be 10, plus the 1 is going to be 11. Now we can multiply that. It's going to be 3 times 11, which is 33. Part B, find GF of 9. Well, I'm going to go to the cheat sheet, so we're just going to work out these parts here, 2 and 3. So GF of x, well, g of x is going to be like the framework of this question. And f of x is going to take the place of x within g of x. That might sound a bit gobbledygook, but stick with me and you'll probably see what I mean when I'm finished. And then at the very end, we're going to, when we have g f of x, we're going to sub in the 9 for x to get that g f of 9. Okay. So, well, g is going to be the frame. So g is 3 to x plus 1. And f of x, this 12 divided by root x, is going to take the place of x here. It's just going to sub into this frame of g. So we're going to have gf of x is going to equal, I think it was 3 and then 2 if we go back. Then we have the x, so we take this 12 over root x and put it in its place. Plus 1. Okay, and then gf of 9. So we have gf of x here. Then I'm just going to sub in 9 for x at this point. So it's going to be 3 in brackets. We're going to have 12 over root 9. That looks a lot easier. Root 9 is nice. So we're going to have this 3. Well, that is going to be 12 divided by 3 because root 9 is 3. And again, we're going to work out whatever's in the brackets first. So we have 12 divided by 3 is going to be 4 plus 1. And again, keep it in the bracket. So 3 multiplied by, well, it's going to be 2 multiplied by 4 plus 1. Well, 2 times 4 is 8, plus 1 is 9. So that is going to be 3 times 9. And that is going to give us 27. And then part C, find the inverse of g with 6 instead of x. So let's go. This is quite complicated now. So for the inverse, we're going to let y equal g of x. We're going to make x the subject. And at the end, we're going to swap x for y. And at the end, we're going to swap the inverse of g of x for x. That might sound awful. It probably does. So we're going to let y equal g of x. So it's going to be y equals 3 to x plus 1. And if I just go back to the cheat sheet, so we've done this part. Now we're going to make x the subject. So we need to expand these brackets. So 3 multiplied by 2x is going to be 6x. 3 multiplied by 1 is going to be 3. I want to get x on its own to make x the subject. So it's going to be y minus 3 equals 6x. We're going to subtract 3 from both sides. Now we're going to divide by 6. So it's going to be y minus 3 divided by 6 equals x. So we've made x the subject. And at the end, we're going to swap x for y. And at the end, we're going to swap the inverse of g of x for x. Okay. So it's going to be g of x equals, we're going to swap this y for x. It's going to be x minus 3 over 6. And remember, we are asked to find the inverse of g with 6. So we're going to swap all of the x's for 6. So that is going to be 6 minus 3 over 6. Well, 6 minus 3 is 3. Divided by 6 is going to be a half. So question 20, show that root 180 minus 2 root 5 all divided by 5 root 5 minus 5. That's not easy to say. Can be written in the form a plus root 5 over b, where a and b are integers. Okay. So it looks awful. It looks like a horrible question, but if we just break this down into stages, really not so difficult. Not so difficult at all. It's an easy 4 marks actually. So if we go to the cheat sheet, so just rule number 1 for this one, and this is my personal rule to you, always just find the next step. Don't look too far ahead. If you look too far ahead, it'll look impossible and you won't want to do it. You'll be scared of it. So don't do that. We're going to use surd rules. We're always going to look for whole numbers from the surd. So for example, if you see a root 4 in the question, this is great because you can just swap it for 2. If you see a root 25, it's great. You can swap it for a 5 and so on and so on. And part 4, we're going to rationalize the denominator when the time comes. And if you want to have a little look at this, you can pause now, but these are the laws of surds, and we are going to be using some of these in this question. Okay. Okay, so first of all, this root 180, I don't like it. The question is asking for in terms of root 5. Now I'm thinking we can use this law here. So root a multiplied by root b equals root a b, or vice versa. You can go in the opposite direction. So if you have, for example, if you have root 3 multiplied by root 4, this is the equivalent of root 3 times 4 or root 12. But you can also go in the reverse direction, which is what we're going to do now. So we have this root 180, but a lot of this is in terms of root 5. So I want to try and get this in terms of root 5 if I can. So root 180 is the same as root 36 times root 5. And then we'll just finish the rest of the equation. And this is perfect. Can you say this root 36 here? On the cheat sheet, if we have root 36, this is fantastic because we can just change this for a 6, which is exactly what we want to do. Just get rid of those surds and get it into a whole number form. So I'm going to do that now. So this is the same as 6 root 5. This 36 becomes just becomes 6 minus 2 root 5 all divided by 5 root 5 minus 5. Just change the color to make it a bit more obvious. So if we have 6 lots of root 5, 6 times root 5 minus 2 times root 5, well, that is just going to be 4 root 5. And then we're going to have 5 root 5 minus 5 on the bottom. And this is where we're up to part 4 on the cheat sheet. We want to rationalize the denominator for this point. So if you have some kind of surd on the bottom, If it's a negative, what we're going to do is, I'm going to change the color again. We're going to multiply by 5 root 5. It's whatever's on the bottom. The only difference is we're going to change this sign. It's going to be 5 root 5 plus 5. And we're going to divide the top and the bottom by the same thing to keep everything equal. So it's going to be 5 root 5 plus 5. If this had been a plus instead of a minus, this would have been a minus instead of a plus. You just do the opposite sign when you rationalize the denominator. 4 times 5 is going to be 20. Root 5 multiplied by root 5. Again, I'm going to quickly take you to the laws of surds. It's going to be this one. So if you have root a multiplied by root a, you're going to just get a. If you have root 5 multiplied by root 5, you're just going to get 5. So root 5 multiplied by root 5 is going to just be 5. So it's going to be 20 times 5. And then 4 root 5 multiplied by 5 is going to be, well, we're just going to multiply the whole numbers together. So 4 times 5 is going to be 20. And then you just put that root 5 there at the end. And now we're going to do 5 root 5 multiplied by 5 root 5, which is, again, just multiply the whole numbers. Multiply the surds. Well, root 5 multiplied by root 5 is going to be, what am I doing? That is going to just be 5. And then 5 root 5 multiplied by 5 is going to be plus 25 root 5. Minus 5 multiplied by 5 root 5 is going to be minus 25 root 5. Let's move this along. And then minus 5 multiplied by plus 5 is going to be minus 25. Okay. Just move this down a bit more. Change the color. Okay. So on the top we have 20 multiplied by 5. That is going to be 100. Plus 20 root 5, which we can't really do anything with at the moment. This one is nice because we have plus 25 lots of root 5, minus 25 lots of root 5, so they are just going to cancel. So now we have 25 multiplied by 5, which is 125, minus 25 is going to be 100. And what this basically means is now, I'm going to put this into a red. It's kind of the same as, well, each term is going to be divided by 100. So you could just put 100 divided by 100 plus 20 root 5 divided by 100. So we just move this up a little bit more. I'm really running out of room. Well, 100 divided by 100 is going to be 1. 20 root 5 divided by 100, a little bit tricky, but if you just 20 goes into 105 times, so it's just going to be, you're going to leave that 1 on the top, so it's going to be 1 multiplied by root 5, which is just root 5 on the top. And then we just have the 5 on the bottom. And if I just go all the way back to the top, so if you have 1 plus root 5 over 5, we have a plus root 5 over b. So we know that we have this. So we know that a plus root 5 over b, well, don't think you need to write this, but just to be a bit clear, we're going to say that a equals this 1, and b is going to equal this 5. And that is our answer. Okay, so question 21. DEF is a triangle, so we have DEF. P is the midpoint of FD, right here. Q is the midpoint of DE, right here. FD equals vector A, which I've just put in there, this green one. FE equals vector B, which I've just put in here. Use a vector method to prove that PQ is parallel to FE. So I'm just going to put those lines in. So PQ is parallel to FE. This one on the bottom, I'll put that in blue. This one here. Okay. Let's go to the cheat sheet. So I think with vector questions, they can be quite tricky. This one's not too bad, actually, but some of them can be really, really, really difficult. Always write down what you know. Trust me, it helps. And for example, even if you don't find the final answer, if you're able to get maybe the first stage or 2 stages, you're going to pick yourself up a couple of marks, which is 2 marks out of maybe 5 or something like that. On a question you don't really know what you're doing is worth it. So always write down what you know. But if you do that, you might say the next step, which is what I would really recommend with these questions. We're going to use FD and D to E to get P to Q. You're going to see what I mean by that in a moment. And then we're going to compare P to Q to F to E and state why it is parallel. Okay. So I'm just going to highlight this now so you can see what I mean. So we need to find what P to Q. And the only way, well, there's other ways to get this, but a way to get to P to Q would be to go from P to D and then D to Q. So I'm just going to write that in now. So P to Q is going to equal P to D plus D to Q. And as it tells us that P is the midpoint of FD and that F to D is vector A, we know that P to D is going to equal half of A. So I'm going to put this in, it's going to be half of F to D, which is going to equal a half of A. So this is this part taken care of. What about this DQ? Well, we know that Q is the midpoint of DE, but we don't know what DE is at the moment. So what is DE? So let's put this in a blue color, this one here. What is D to E? Well, D to E, if we want to go from this point here, D to E, we need to go from D to F and then F to E. Well, D to F it's not going to be A, it's going to be minus A, because F to D is A, but D to F is the opposite direction. So D to F is going to be minus A. And then F to E is going to be plus B. So D to Q is going to be, I'm just going to put this in here, D to Q is going to be a half of D to E. And I know from this part here that D to E is going to be minus A plus B. So that is going to be plus a half of minus A plus B. I'm going to change this to black so we can see what we're doing now. So keep the half A from P to D. And then for D to Q, well, a half multiplied by minus A is going to be minus a half A. And then a half multiplied by B is going to be plus a half B. So this is going to be minus a half A minus a half A again, plus a half B. If we just go down a bit more, well, we've got half A minus half A. Well, they are going to cancel out, and it's just going to leave us with a half B. So PQ, or P to Q, is a half B. So I'm just going to write that in there for P to Q. That is going to be a half B. So F to A equals B. P to Q equals a half B. You could say F to E equals 2PQ. Therefore, it is parallel. Okay, so question 22. The diagram shows two shaded shapes, A and B. So you've got A here, B here, this circle. Shape A is formed by removing a sector of a circle with radius 3x minus 1, which is this sector here in white, from a sector of the circle with radius 5x minus 1, which would be this whole length. I'm just going to put that in now, just to make it a bit clear. This bit here. So we've got 3x minus 1 and 2x, and that is going to be, like it says in the question, 5x minus 1 centimeters. And then for shape B, well, shape B is a circle of diameter 2 minus 2x, which you can see here, centimeters. The area of shape A is equal to the area of shape B. Find the value of x. You must show all your working. So if we go to the cheat sheet, I think what I might do here, I might just do this one stage at a time, because it is quite a long question. It might help you. So let's just look at part 1 of the cheat sheet. So the area of A equals the big sector subtract the small sector. Okay, and just for a bit of reference, the area of a sector, well, a sector is going to be, it's a portion of a circle. So we're going to have the formula for a circle, which is pi r squared, for the area of a circle, which is pi r squared. But it's not going to be the full circle. It's only going to be that portion. And we can work out that portion by using the angle. So we're going to have multiplied by theta, which is going to be this angle here, which in this case is 45, divided by 360. And if you work that out, 45 divided by 360, it works out to an eighth. So this part of the circle, this sector here, it's kind of like an eighth of a circle, and that is what this formula gives us for this sector. Okay, so for the big sector, well, we know that it's going to be pi, well, the radius here is going to be, remember the big sector, which is why I wrote this in, it's going to be 5x minus 1. Squared. Multiplied by theta over 360, well, it's going to be 45 over 360. That. Subtract the small sector, which is going to be, going to have pi, the radius for this one, the small sector, this white one, is going to be 3x minus 1. Again, all squared, pi r squared. Multiply again, same angle, multiply by 45 over 360. Okay. So let's expand this out. So we're going to have pi, we're going to have 5x minus 1, 5x minus 1 multiplied by, well, that is going to reduce down to 1/8. That's 45 over 360. Just going to put that like that again. This is going to be a very time-consuming question. It's going to take a little while. So again, we're going to expand this. We're going to have 3x minus 1, 3x minus 1 multiplied by 1 over 8. Again, we're running out of a little bit of room, but I'm going to try and fit it all in. And what do we have? Well, we have pi, we're going to have 5x multiplied by 5x, which is going to give us 25x squared. 5x by minus 1 is minus 5x. Minus 1 by 5x is minus 5x, so that's going to be minus 10x. Minus 1 by minus 1 is minus times a minus is a plus. So we have pi, 3x by 3x is 9x squared. 3x times minus 1 is minus 3x. Minus 1 times 3x is minus 3x, so that's going to be minus 6x. And then again, minus 1 by minus 1 is plus 1. And that's all multiplied by 1 over 8. And just to tidy this up, so I'm going to say it's going to be 25x squared minus 10x plus 1 pi. And then instead of saying multiplying by an eighth, you could just make it a bit easier and say it is divided by 8. And this one is going to be the same, so it's going to be minus 9x squared minus 6x plus 1 all multiplied by pi all divided by 8. And I think for now I'm going to leave it like that. So I'm going to check this one. Now we're going to look at b. We need to remember that the area of a circle is pi r squared. And again, we need to also look at number 3. So the diameter is going to be, it's 2 times the size of the radius. So the radius goes from the edge of the circle to the center. The diameter goes from the edge to the center and then to the other edge. It's going to be double the size of the radius. Okay. Let's put this into blue now. So we have, for b, well, we know that the area of a circle is going to be pi r squared, but we don't have r yet. We have d, we have the diameter, but we don't have this radius. We have the diameter, we don't have the radius. We just need to half this. So d equals 2 r. So r is going to equal d divided by 2. So what is d? Well, d is 2 minus 2x divided by 2. So this is going to cancel out. So you're going to have 1 minus x. So the radius is 1 minus x. Let's just draw a circle around that. It's going to be squared. So we're going to just expand those brackets again. We're going to have 1 minus x. 1 minus x. Well, 1 times 1 is going to be 1. 1 times minus x is minus x. Minus x times 1 is going to be minus x. Minus x times minus x is going to be plus x squared. Let's just tidy this up and put the x squared first. So we're going to have x squared minus 2x plus 1, put that in brackets, all multiplied by pi. And if I go to the cheat sheet, we've used that area of a circle, and we've used that diameter equals 2 times the radius. Now we're on to part 4, where we have the area of A equals the area of B, and this is when we can start to eliminate certain things from the equation. So you can see here that this value here is the area of A. It looks awful. It looks very, very messy. This one doesn't look particularly nice either. This is B. It looks a little better than A. But these two equal each other. It tells us in the question, it says, if I just zoom in, the area of shape A is equal to the area of shape B. That's very important. Okay guys, I'm really sorry if you can't see this upper part here. I've really had to sort of zoom out so I could see everything that I was doing. But what I've done here is with A, well, both of them have 8 as the denominator. So what we can do is we can just put all of this over 8. So everything can go over 8 for A, and then on the other side we have B. So what I'm going to do immediately, well, I can see that this 8, I want to get this off the bottom. I want to get this over here. So I'm going to multiply both sides by 8. And we're also going to have 8 multiplied by this side. So that gets rid of the denominator. Now we're on an even keel, let's say. So this makes it a lot easier. And I think the next thing that we can do here, we can eliminate this. We have pi on both sides. So I'm just going to divide both sides by pi. I'm just going to move this up. Okay, so now I think it's just a question of simplifying this. So we have, I'm going to get the x squareds first of all. So we have 25x squared minus 9x squared. Well, that is going to give us 16x squared. Then with the x values, well, we have minus 10x minus 6x. So that is going to be minus 10x plus 6x. So it's going to give us minus 4x. Let's just cancel these out as we're going. And then we have plus 1 minus plus 1, and that is going to be 0. So we can put equals. And on this side, we're going to have, I'm going to multiply this out. So we're going to have 8 multiplied by x squared, which is going to give us 8x squared. 8 multiplied by minus 2x is going to be minus 16x. 8 multiplied by 1 is going to give us 8. Okay, and now we just need to get everything on one side. So what do we have? We have, well, I'm going to subtract 8x squared from both sides. That will give us 8x squared. I'm going to add 16x from both sides. So that's going to give us plus 12x on this side. And then I'm going to subtract 8 from both sides. And that will give us minus 8. And that is going to equal 0. Okay, and I'm going to just simplify this a little bit more. So I'm going to divide, I think all of these are multiples of 4. So I'm going to divide by 4. That's going to be 2x squared plus 3x minus 2 equals 0. And for this part, we're going to factorize. So I need to find, well, one of these has got to be 2x, and one of them has got to be x to get to 2x squared. So one is going to be 2x, one is going to be x. So we need to find two numbers that are going to multiply together to give minus 2. If we solve this, if we multiply out these two brackets, but then give the 3x here. Well, with minus 2, there's only two numbers you can have. It's either going to be, or two forms of the numbers. You could either have minus 2, 1, or you can either have 2, minus 1. That's the only combination that you have to give you minus 2. So minus 2 times 1 is minus 2, 2 times minus 1 is minus 2. But the trick here is putting this in the right order to give you plus 3x. So I want, because this is plus 3x, it's a positive, I'm going to multiply the 2x by 2. I'm going to say it's plus 2. And that would give us 2x multiplied by 2 is going to give us 4x. And if I put the minus 1 here, well, minus 1 multiplied by x is going to bring it down 1 to 3x. I'm happy with that. That is looking very good. Okay. So now we're going to have, it's either going to be 2x minus 1 equals 0, or x plus 2 equals 0. So 2x minus 1, so if we add 1 to both sides, 2x equals 1, and then we divide 2 from both sides, that is going to be x equals a half. That is one of the solutions. Or we're going to have, well, x plus 2 equals 0, subtract 2 from both sides, that will be x equals minus 2. So when we look at this sector, it really is not possible for this sector to be negative. For example, this length here of A, we have 2x. Well, if it was minus 2 for x, it would be minus 4. And it can't be minus 4 centimeters. It's not possible. So as x cannot be negative, x must equal a half. So question 23, last question. There are 4 types of cards in a game. Each card has a black circle or a white circle, which would be here, or a black triangle or a white triangle. The number of cards with a black shape to the number of cards with a white shape are in the ratio of 3 to 5. The number of cards with a circle and the number of cards with a triangle are 2 to 7. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Okay, so we go to the cheat sheet. What we're going to do here is we're going to make the two ratios given. We're going to try and make them link to each other by making them equal, if possible. And we're going to use this information to find the fraction that we need to find. So, when we're looking at the number of cards with a black shape and the number of cards with a white shape, this is given in the ratio of 3 to 5. So therefore there would be 8, you could say 8 parts to this ratio here. If I just change the color to blue, And the number of cards with a circle and the number of cards with a triangle are in the ratio 2 to 7. This is in 9 parts. I want to try and get these equal. So if we have 8 times 9, well, that is going to be 72. So what I'm going to do is I'm going to multiply this one with 8 parts by 9 to get to 72. And I'm going to multiply this one with 9 parts by 8 also to get to 72. So I'll put this in green. So we have black to white. So at the moment it is 3 to 5. So what I'm going to do is I'm going to multiply by 9. Well, 3 by 9 is going to give me 27. 5 by 9 is going to give me 45. And what do we have? The number of cards with the circle. Let's put that in. So circle to triangle is, at the moment, it is 2 to 7. And we're just going to manipulate that a little bit. We're going to multiply this one by 8. So 2 by 8 is going to be 16 for the circles. 7 by 8 is going to be 56 for the triangles. If you add these both up, they will both give you 72, I hope. So 27 at 45, that would be 52. Yep, that is going to be 72. 16 at 56, again, that equals 72. So we are good now. So express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Well, 27 out of 72 are black, and 56 out of 72 are triangular. So therefore, black to triangle is going to equal 27 over 56. And that's the end of the paper, guys. Thank you so much for watching. I hope this helped you. If you've got an exam coming up, good luck. And yeah, I will see you in the next one. Thank you so much. Bye-bye.